This flux. Jeff, you can't hear me, is it? Can hear me? Can hear me or not? You only 28. Today I'm not going to put. Jeff, puasa tak boleh cakap ya. Tak boleh cakap ya.
Boleh. Saya lupa
Of the
Ustaz.
flux.
Jeff lapar tu.
What's the function of this flux?
Remove outside, promote it.
Oh my god. What the sound like this? Okay, so they mix together and do mixing, then they got this one lah. So when they use the stencil, still remember? Okay, so first they put the soda paste, they have a squeegee stencil. So this soda paste will just fill in the cavity lah. Okay, this is all the bonding pads, all the bonding packs. So after that they remove the stencil, then leave only this one. And this one, the powder, after reflow, it will form a bigger ball. It will form a bigger ball. So this is the printing machine. Printing machine. This is the inside. This one is the stencil. Okay. They put the paste here. They have the squeegee print. So this is the one paste. So you have many sizes. Depending. So they label by number. So the bigger the number is, the smaller the particle size of the soda powder. Okay, so it's a mixture of powder and flux. We call it as a soda paste. Okay, so SMT processor, they normally use this one. So I promise to show you the oven. Something like this, very long one. Okay, so the computer screen will show each zone, different temperature. This one is set by the engineer. Okay, so basically the oven inside you have many zone, right? So the unit will travel, will flow like this. The product will flow like this. Okay, it have a conveyor belt. So this is it's very long. So inside there actually you have many zone. Okay, so start you rank up and soak. Soak is for flux screening. After the flux screen away the oxide, then only reflow. Okay, only reflow. Melt the soda. Then when you want to come, the unit is going to come out. Then you need to do cooling. Just like you do thermoplastic, and you want to shape it, then you need to cool it. So soda also the same. So it will travel here, go in, close, travel in. There is a conveyor belt. Go, and here. So the belt is rotating like this. Okay, so the speed is controlled by the belt. So how long? Okay, from here to here, how long? So this is the one. Okay, we continue on. So basically, in the flip chip, we have silicon sealant. This one is polymer. Silicon sealant. Okay, this is silicon interface material. The function is to let the heat to be evaporate. What is this? The brown color thing. This one is called heat sink. Okay, heat sink. So this is underfill. So this is flip chip. Flip chip. This is underfill. Underfill is epoxy. Okay, so you have a dye, soda bump. So you have a substrate. Okay, substrate is the core layer is epoxy. Okay, then the surface they use their epoxy solder resist. The core layer is epoxy. But sometimes they use this one. This is the one type of epoxy. Okay, they have a core so that it will become harder, very strong. So surface solder resist. Why call solder resist? Resist to solder. So the solder won't form joint out from the bonding pads. Okay, so it will just form the bonding here on the bonding pads only. It will not form joint on the green color one. This is what we call solder resistant, like this. Only sit inside this pocket, bonding pads. It will not form joint over here because epoxy and metal, one organic and one inorganic cannot. Adhesion very bad. Adhesion is very bad. So that's why they call solder resist. Okay. If wire bond, remember wire bond no bumps. Okay. We just use adhesive. Okay, we just use adhesive. Okay, this one is polymer. Then this is wire dye. Okay, the substrate the same. You have solder resist layer. You have the core layer. Okay, then in between you have many multiple copper trays. Then because you are using wire, okay, you need to protect the wire and also the dye. Then we use encapsulate, also known as mold compound. This one normally phenolic mold compound is using phenolic. Phenolic is thermoset or thermoplastic? Phenolic is thermoset or thermoplastic? Murray?
Thermoset.
Thermoset. Okay. Demand for polymer that used in this industry. Of course, we must fulfill the high reliability requirement. Okay, high reliability must be able to function well and also demanding environment. So you are dealing with many kind of environment, such as temperature. Now I say temperature is going up. Okay, moisture, chemical, all that. So requirement must be high dimensional stability. So dimension must be stable. That's why we use the thermoset. So no, we don't use thermoplastic because thermoplastic cannot stand very high heat. But for the one to import to travel to transport the unit, the one can use thermoplastic. The tray. Okay, so excellence, thermo oxidative resistant, because deal with oxygen. So you must be oxidative resistant, especially polymer is very sensitive to oxygen, right? And good chemical resistant. This one because we deal with many chemical. Okay, so must be chemical resistant. Low moisture absorption, you see, because you heat up and you cool it down. Okay, so might have moisture capture inside. So your units the polymer must be low moisture absorption. Of course, high mechanical plus high stiffness. Okay, and high compressive strength. This is all the demand. So our target is we want to have a very good performance. Okay, good reliability. So in order to achieve this one, actually, is depending on these three: structure, processing, and property. Okay, so structure, how you familiarize your materials. Okay, composition. What's the composition of your materials? You use pillar, matrix, um, adhesion promoter. Okay, lactic is what? Lactic is the design. Okay, plus the design and the bonding. The material in between materials and materials, how's the interaction? Must be able to form bonding, good interaction, so that you will give a good properties. Okay. Secondly, processing. So equipment must be stable. Don't always have downtime. Okay. So the high productivity and high yield. Okay. So properties, as you know, the MOSFET, when it's uncured, is in liquid, right? So anything in liquid is regarding to flow behavior, your rheology. That's why you need to learn about rheology. Like thermoplastic, when it's melting, is also in liquid. So rheology is also important. So flow behavior is important. Mechanical, thermal dissipation to dissipate the heat, and electrical conductivity. Let's see how many is joining. 30. Today I'm not going to send the attendance inside your WhatsApp group. Once in a while I will send. But once in a while I will not send. But normally I will send. Okay? So if you are not attending, you are not signing in the attendance, then you need to be careful. Then I post the link one more time. Okay. This is to thermal conductivity. So polymer normally is insulator, but you have polymer, conductive polymer. This one, Dr. Zina will cover it. Okay, then you have semiconductor, metals, and superconductors. And this is the how they can the die. Okay, can face up, face down, and also bit cheaper. When you see that, okay, so you must up to now you must able to differentiate between wire bond and flip chip already. Okay, when you see more compound encapsulate, normally is wire bond. Okay, definitely no solder bumps. Okay, when you see underfill and solder bump, it flip chip. Okay, it flip chip. Okay, the next topic we're going to learn underfill. We are going to learn underfill. So what is an underfill? Where is underfill being located? Here. Okay. We have in pre-chip technology, wire bond will not have. Wire bond will not use underfill. If wire bond, I see the word underfill means you lost or you didn't come to the class. Okay? The concept is wrong, then everything will be wrong. You need to be careful, yeah? Okay, so in flip chip technology, the gap between substrate and the chip, the die and the substrate, there's a gap, right? Why there's a gap? Because we have solder bumps. Okay, the gap height will be the solder bump height lah. Okay? Okay. So it's underfill with high fill epoxy system. It's a composite. Okay, with filler. Okay, so this is underfill. Because it's underfill underneath between the die and the substrate. And go through all the bumps. So it's called underfill. So underfill behavior must have high modulus, low CTE, high modulus and low CTE. Okay? So what is the role? What's the function? Provide reliability to the flip chip package. And later we will see in detail why it can provide reliability to the feed chip package and distribute the stress due to CTE mismatch. Okay, I hope you still remember what is this, yeah? CTE mismatch means different in CTE value, different in shrinkage and expansion rate. Okay, so dye, as I say, only 2 to 3 ppm per degree Celsius. This substrate is polymer, can go up to 80 to 100. Okay, ppm per degree Celsius. So it's huge difference. So metal is in between these two. Metal is around 40 like that, 30, 40 or 20, yeah, something like that, depending on what type of materials. So CTE value is different. That's why you have CTE mismatch. So it will generate thermal stress. Okay, it will generate thermal stress. Yeah. So later we will see. So prevent interconnect fatigue. So if you have stress, then fatigue will happen. The fatigue will happen. Happen to what? To where? To these solder bumps. Because in between and the substrate.
Disconnect.
Connect. Okay. No current flow. No signal flow. Okay. So it's correct. Okay. Very good. So no current flow. So disconnect. So what's the purpose of putting these solder bumps? To give interconnection. Okay. Okay. So this is a picture. This is the picture. Very simple picture. If you must understand the picture well so that you can explain. So I put, you see, I put big picture and less explanation. That's mean if you understand the picture, you can explain. You can write many things. Normally you don't like to see many words run, right? So I only put one picture. So this picture you must understand. After my explanation, if you don't understand, you let me know. Okay. So this is the mechanism. The underfill encapsulation. Underfill encapsulation for solder joint protection. You give protection to this solder joint. Where's the solder joint? This one. What is this? This is die. Okay. This is die. This is solder bumps. Okay, not necessary you must draw it as round. Some people like to draw like this. Okay, but you need to label lah. You need to let me know. All this got point one, you know. As I say, all this got point one. So you must label. If not, how will I know? If without this one, what is this? What is this? What is this? This is die. This is solder bumps. So this is solder joint. So this is substrate. Okay. So one, the upper one without underfill. See? No underfill. Without underfill. So the bottom one with underfill. Tak lah. Saya nak tengok Nisa ada join tak? Wah, Nisa ini that's why hari ini saya tak mau bagi attendance lah. Dia tengok attendance dekat group, lepas tu dia sign in. Dia langsung dia tak pernah join. Dia tak pernah join kelas saya. Sudah 3 kali loh. Sudah 3 kali. Apa terjadi kepada Nisa? Ansat. Nasri ada join tak? Nasri. Ada, nasib baik. Lagi seorang. Tadi yang tak join. Yasha, nasib baik ada join. Lagi seorang. Esther. Ha, ada, nasib baik. Nasib baik Okay. So we continue. So the bottom one you see with underfill. Okay, with underfill. So what's the difference? Okay, you see without underfill one. Okay, so if you have reflow temperature, at reflow temperature means heating lah. Okay, you heat, then you cool. You heat and you cool. Okay, then expand string, right? Okay, after multiple cycle, it will generate the thermal stress. Why? Why can have this stress? Because of the image match. Because of the CTE mismatch between these materials, especially dye, you have 2 to 3 ppm per degree Celsius substrate, 80 to 100 ppm per degree Celsius. And this solder joint is around 20 to 40 lah. So different reference shrinkage with different expansion rate. So you will generate thermal stress. Okay, if without underfill, the stress will all go to your solder joint. Will all go to your bumps. Okay? All go to your bumps. And then after some times you will have fatigue. Okay? Fatigue. Jangan nampak perkataan fatigue sudah panik. Apa ini? Apa ini? Inilah gambar ini yang akan explain. So you will have fatigue on solder joint. Tak tulis dekat sini kan? So kena dengar baik-baik. Dengar baik-baik. So you will have fatigue on solder joint. Tak datang kelas saya tak tahu. What is fatigue on solder joint? Apa benda ni? Takkan tahu lah. So I tell fatigue on solder joint is like a crack. Okay? So you will lose your connection. No connection at all. Okay? Okay, so let's see if we have underfill. Okay? If we have underfill, it will transfer the stress to the underfill. That's why the joint is compressed and protected by underfill. Interlock by underfill. Okay, if you have this underfill, the stress it will go to underfill. Okay, it will go to underfill. So your solder joint will not have fatigue. Okay, will not have fatigue. So heating, cooling multiple time. But one disadvantage is if you have underfill, it will have what we call this one. You see what's the difference between this one and this one? This one already like curve, right? Okay, if you see properly, this one is like have curve, right? It's not straight, right? What is this called? What is this called? This is called, it will warp. Okay, it will warp. Okay, then you will have warpage. Then you will have warpage. Then you will have warpage. Okay, So warpage at certain what we call at certain level, okay, you can measure the warpage actually. What's the difference between original must be straight, right? They can measure actually how much different, okay, how much different, okay? So see, there's a difference so they will measure this one. So also cannot be too severe also cannot be too severe. If too severe, what happen if too severe? It will cause problem on second level when you do your motherboard. Okay, when you do your second level interconnection. Okay, so imagine this is your solder board. So you already warp, right? Okay, so you will do for test, right? Okay, when the problem will be warpage, when the problem come will be when you do the second level, whereby you need to attach on the PWB, right? So when you have severe warpage, then this one it cannot attach on your PWB. You see? So they said there's a what we call upper and lower limit. Upper and lower limit. This one only can work by how many mm? Okay, so that is another challenge. Okay, but then your solder joint can be protected. Okay, up to here, can understand? Up to here can understand? Can Mutri boleh tak? Mutri.
Boleh.
Boleh Nasri?
Boleh, Doktor.
Okay, so I continue Faham So this is how underfill contribute to no, not contribute. This is how underfill prevent, okay, or protect or prevent the solder joint fatigue. Okay, this is how underfill prevent the solder joint fatigue. Or this is how underfill provide protection to the solder joint. Can follow, Okay. Okay. Can I move on? Can I move on?
Ya, Doktor.
Okay. So this just to show you how they dispense underfill on this package. Okay, one way is capillary underfill. So the capillary underfill, the underfill is inside here. So the underfill, they will just dispense at one side. At one side. Then, due to the capillary action, the underfill can fill in. Of course, you must apply some temperature so that epoxy, right? I want to ask you. This epoxy is thermoset, right? Okay, so thermoset, when we apply temperature, the viscosity, what will happen to the viscosity? Become higher or become lower? Son. 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 Son juga puasa ke? Son. Tak ada. Biasa Son ada kan? As.
Ya, doktor.
Viscosity. Okay, thermostat when you apply temperature, viscosity will become higher or lower?
Lower.
Lower, eh? Very good. It will become lower, so it's easier to flow. Okay, so during the process, it will apply temperature on this package. Okay, so it will flow from one side to the other side. Okay, so this is called capillary underfill. Another type is no flow. No flow means they inject they dispense the underfill first. Okay, then after that, they place the unit. That's another one. So another one is molded underfill. Molded underfill is underfill normally up to here only, right? If you see molded underfill means two function: protect the bumps and also protect the die. So this whole thing is underfill lah. So that's why they call it as molded underfill. Okay, then this one need to do using transfer molding. Okay, just now the capillary action. This is the one last time when you study chemistry, you go inside the lab, you do experiment, right? Okay, so water, mercury. So water, you will have a capillary action. Okay, but mercury will not lah. You will have repulsion. Just to show you. Refresh. Okay, so conventional underfill process. Okay, so you this is your dye. This is your substrate. Okay, so sometimes they will put flux also lah, because you have flux residue on this bump, because you need to clean away the oxide first so sometimes you will put the flux first to clean the oxide on body solder bumps. Okay, then only they put the underfill, or else if you have oxide layer also, you will not have a good bonding okay, between this underfill with the solder bump also. Okay, this is one of the example lah. Okay, fluxing underfill. Fluxing underfill right now they mix the flux inside the underfill already. Okay, some of the factory they use this one means 2-in-1 just now is do the flux first, right? React and clean away, then only do the underfill. So they also put the flux material inside the underfill. So slowly increase temperature, then the flux will take reaction to clean the oxide layer on the solder bump. Then only the underfill will cure lah. Okay, so this is then only go for reflow means curing. Okay, so this is another method. Hybrid underfill. There's another method over right now in research. They use the hybrid underfill, whereby for all the while they attach the solder bump on the die, right? Okay, that's another solder bump on the substrate, and this one is whereby they put still remember just now I show you the solder paste. Instead of the solder paste is the flux and the powder, right? Metal powder, and this one is together with underfill. actually is 3-in-1 lah. So they put the flux, underfill, and also the metal powder. So that they do printing. Is printing. Okay. So after slowly increase the temperature. So after reflow, all this powder, you see, all this powder is tiny, tiny one, right? After refill, because melt already, they will join together and form a soda bomb. Okay, bigger soda bomb. Okay, this one is not going to come out in your exam. It's not going to come out in your test. Just show you the current technology. They can have idea something like this. Okay, macam-macam boleh mereka buat. Okay, come to this one. Okay, capillary underfill process overview. This one I want to explain to you how they do the underfill process. Okay, how they do. So only 5 test steps. Okay, first one, okay, you see, one is prepared and one is preheat. Why this one they don't use preheat? Because want to differentiate from this one, if not too preheat. People might confuse, right? So they put this one in prepared. Prepared is what? Prepared is what? Like your calcium carbonate, you tends to, like your silica, it tends to absorb moisture, right? So before you compound, you need to put in oven to remove the moisture, right? So same thing lah, the package, because it's polymer, tends to absorb the moisture. So you will have moisture and trapped inside the package. So before you do the process, you must put in the oven. Okay, put in the oven, then to let the moisture to be evaporate, so that you will not have this wash after that. If you have moisture, you put the underfill, reflow, right, or curing you apply heat, right? This moisture 100 degree, it will evaporate, so it will leave voids. You will leave the voids inside your underfill, so this will cause defects. Okay, so remove the moisture inside your package first. Okay, means this whole package they put in oven. Okay, to remove the moisture. Okay, after that, after remove faster, they will transfer into the machine. Okay, into the machine. So on the machine, we must apply some temperature. Okay, we must apply some temperature. So that's why we call it as preheat lah. Preheat on the machine. Why? Because if the machine, the processing without temperature, so when your underfill flow, the viscosity will be high lah. It will be difficult for you to flow. That's why you must preheat. Okay, during the processing, you must apply the heat. Okay, once the unit exited from the prepared oven to a machine, then you must set a desired temperature to ease the flow, so that you can bring down the viscosity, then the underfill easier to flow. That's the purpose. Okay, one is to remove the moisture, one is to ease the flow of the underfill. This one still we do not put any underfill. Okay, this one is when we dispense the underfill. Okay, so after that, you preheat, reach certain temperature that only you can dispense. You can put your underfill materials on the unit. Okay, on the unit. Then only your underfill can flow through the capillary action, from left to right or from the right to left, and cover the entire die area. After cover it, of course you must cure it. Okay, you must cure the underfill materials to achieve a desired mechanical properties. Also, up to here, anyone cannot follow. Anyone cannot follow. So actually, it's just common sense. Every step it have its own objective, its own purpose. Okay, so Capillary underfill is a low viscosity liquid are designed to flow under the component by capillary action. Must be able to wet, okay, wet the chip and also the substrate surface so that they can form bonding, okay, and protect, okay, your solder joint. So underfill is more sensitive to moisture because it's polymer, okay, so it can form voids. So that's why during the processing you need to preheat. Okay, you need to preheat. Then after that dispense. Okay, after preheating and dispensing normally do together. Okay, to avoid extended expose of moisture, to avoid your moisture being absorbed inside your package. Then you will cause voids. Huh? Okay, so normally they will dispense here. So this is top view, you know. This is your substrate. This is your die. Side view, this is your die. This is your substrate. Okay, the underfill will have like that lah. They call it a side fillet. Okay, must have side fillet. If not, we will be have incomplete fill. Okay, so every process will have one tongue. What is this tongue? Is whereby you dispense your underfill here. Okay, you dispense here. If you dispense here, there will be have one shape like tongue. They call it a tongue. Okay, side view, top view. So must have fillet lah. If not, it's incomplete lah. Okay. Okay. So processing issue. When we do underfill process, okay, first you must optimizing your dispense weight and pattern. What is this? How much you want to dispense your underfill? One time, how much you dispense? Must be consistent. Cannot like one this time more, another time less, then medium, then all the this fillet width will be different. Some will have incomplete, then some will have excess up to here, flow up to here. Correct or not? So how to control? Normally they control the weight. Okay, and each time pattern, each time where to dispense here. So it will tell the computer, the robot, okay, there's a computer screen, they will have drawing, they put here, this point. So how to recognize? So normally on the die, we have a mark here, triangle mark here. Okay, so the computer will recognize this one, then like go down how many distance and come here. This is where they dispense. Cannot suka-suka hati, one time here, one time here, and another time here. No lah, must be complete exactly, standardized. Okay? Okay, so that's how you control your the width. Okay, see the width. Below width is which one? This one. Cannot be more. If more means wasting your materials, then it will travel up to here. Okay, so this is how they control the fillet width. So underfill voiding control, just now the moisture absorption, remember? So avoid excessive interaction of process heat to the underfill materials. Okay, before you dispense your underfill materials, for example, the underfill material is in syringe, right? These strings try to avoid to expose to temperature because once temperature is already formulated, your hardener, your catalyst, your epoxy are all already inside, already inside here. So if temperature means curing will start. Okay, curing will start. So it will affect your port life of your materials. If your materials, your epoxy haven't done the process already cure inside your syringe, that will be a loss. Your boss will question you. What happened? Okay, so you need to be careful. That's why you need to have knowledge about polymer lah. Okay, or else you might question, why cannot apply to temperature? Why? Because curing, it will become hardened. Okay, if not, people might question, why a supposed temperature will become hard? Is it magic? So as a polymer engineer, you must be able to explain. Okay, so expected you, especially the syringe, don't drip on the unit. You want to dispense here, but make sure your robot don't go and dispense here. Or your underfill materials, the viscosity too low, when the robot is travel over, it drip on your die. That will cause defects, reject. Okay, or underfill on die. Incomplete filleting also. Okay, very less, not enough. Only fill up here, up to here only. Incomplete lah. Okay, incomplete. So your equipment must be stable and capable lah, so that you can produce high productivity and high yield. Okay, every day your job is to make sure high productivity and high yield, and make sure you hit your yield percentage. That is your job if you want to work as process engineer. Okay, that is your job. Okay, I think I will stop here. I continue on Thursday. So any question before I end? No, so far so good.
Yeah.
Okay, bila nak habis semua orang buka suara. Bila tanya soalan, tak mau buka. Itulah culture student sekarang macam tu.
Malu.
Malu? Tak payah
Puasa.
malu. Kan first time meet saya. Saya pun tak nampak you punya muka kan. Puasa tak boleh buka mic. So nanti lepas raya jawablah. Semua boleh jawab lah kan.
Boleh.
Ada soalan tak before we end? So far you can understand or not? Can understand or not?
Yeah.
Okay, important thing is you can understand, because it's totally new to you, right? Okay, so I hope you can follow lah. If you can follow, cannot follow, just let me know. Okay, kalau malu message saya. Okay, boleh?
Okay, doktor.
Thursday 3:30 again. Okay, so siapa belum sign in attendance, the link I post one more time. Sudah 4 kali saya post. Kalau you masih tak dapat lah, saya tak tahulah. Tak tahulah kenapa tak boleh dapat. Sudah 4 kali kan.
Kalau dah isi sebelum awal ni, kena isi lagi.
So kalau awal tu you drop line tu tak dapat tu, okay. Sekarang saya post 1 kali, 4 kali tu. Yang tak ada drop tu. You tanya Chai Mei. 4 kali kan Chai Mei? I posted 4 times. Siapa ada tak yang tak sign in lagi? Sebab saya tak akan post inside the WhatsApp group. I want to let Nisa know. Cannot always don't attend. This one you don't attend, you cannot follow. Final year already. Okay? Bukan saya nak apa? Sengaja tak mahu kamu, sengaja nak kamu terima surat. Bukan. Saya nak you faham. Jangan nak extend. Nanti masa convocation saya nak tengok you dekat sana, yo. Okay? Siapa belum sign in, beritahu saya. Kalau tak, saya akan turn off.
Sign in apa, doktor?
Apa enough? What enough?
No, send in apa tu?
Sign in attendance.
Oh, belum lagi.
Attendance.
Nak
Oh,
lihat.
itulah. Nanti saya tak akan masuk dalam WhatsApp group. Saya mau bagi satu pengajaran. Cepatlah. Saya bagi. Okay, siapa yang sudah sign in tu boleh drop. Nanti saya tengok. Siapa yang boleh sudah sign in okay, bye bye. Boleh drop lah. Okay.
Doktor,
Thank you, doktor.
Okay.
yang
Ya.
notes yang ni boleh doktor tolong share dekat tu lah.
Ya. Saya lupa pula. Okay.
Thank you.
Nanti saya buat. But while waiting for you all to find the attendance, I do now.